Hello, my name is David, and this is how I made a simple snake game with Python and Pygame. To get started with this project, you need to ensure that you've installed Python 3 and also the Pygame Community Edition. For step 1, we're going to create the Pygame window. The Pygame window is going to have a title, then we'll set up the width and the height of our window. I've already created a main.py in my project folder, and I've imported the Pygame module. The first thing we need to do is to call the Pygame init function to initialize Pygame. Next, I'm going to set the screen width and the screen height as constants. For the width, I'll set 600 pixels and the height 400 pixels. To create the window, we use the pygame.display.set mode. And here we have to pass the screen width and the screen height. We're going to use pygame.time.clock for the FPS, frames per second. Define a while loop, so while through to ensure that the game continues looping. And we're going to check for all the users' events using this for loop. So we'll loop through all the events triggered by the user. And then we're going to check for the quit event. The quit event is basically when the user clicks on the close button at the top right of the window. And then I'd like the Pygame to quit and also the window to close. So I need to import the sys module as well. So let's see how our window looks. I'm going to run Python main.py to launch the window. And this is the window we get. You see here, we have a black window, and the title for now is Pygame window. So let me close it with the close button. To set the title for the window, we use the pygame.display.set caption. We're going to call our title Snake Game. This time you see that the title is called Snake Game. For step 2, we're going to draw the border for the game area. Basically, the boundaries for the movement of the snake. So I'm going to define new constants, boundary x, boundary y, boundary width, and boundary height. For boundary x, I would like 25 pixels, 45 for boundary y, 530 for boundary width, and 330 for boundary height. And then for the boundary color, I'm going to define a new constant called brown. To draw the boundary, I'm going to use the Pygame.drawDirect, pass our surface, which is our screen, the window we created earlier. And then for the color, brown, the constants we created earlier. And then I'm going to draw rectangle using Pygame.rect, and then pass the boundary x, y, boundary width, and height. So if I save that and run the game again, you see that nothing is displayed. So to actually display our boundary, we need to ensure that we always update the display. And now you can see that we have a boundary, but you can see that it has a fill color, which is not what we want. So I'm going to set the optional width to 2 so that we get just the border. After launching the game again, you observe that we get only the border of the rectangle, which is what we want. For step 3, we're going to draw the snake. So the way we draw the snake is by using boxes of 10 by 10 pixels to build the snake. So in the beginning, we'll have 3 of these boxes. So the snake will look like this. For the first box, we'll have a position of 100 for X and 100 for Y. For the second box, X will be 90 and Y will be 100. And for the third box, X will be 80 and Y will be 100. So I want the snake to be yellow. So I'm going to define a constant to store the value for the yellow color. For the actual head of the snake. For the head of the snake, I'll define a list 100 by 100. So 100 for X, 100 for Y. And then for the snake body, we're going to store a list of lists. And each of these lists will be for each of the boxes. So for the first box, the coordinate will be 100, 100. For the second box, coordinate will be 90 for X, 100 for Y. For the third box, the coordinate will be 80 for X, 100 for Y. Now to draw the snake, we're going to loop through the snake body. And for each position in the snake body, we're going to draw a rectangle. We draw the rectangle on the screen surface with the color yellow. And for the actual rectangle we're going to draw, we're going to pass the X value of the snake position, which is the first item on the list, and the Y value of the snake position, which is the second item of the list. For the width and height, I'm going to declare a variable called grid size. And grid size will be a constant of 10 pixels. So let's run the game and see how it looks. And yeah, that is the snake of length 3 boxes. Now we need to move the snake. So remember that the snake is made of 3 boxes. To move the snake, we'll add a new box to the head of the list. And this will now become box 1. And its position will be X equals 110 and Y equals 100. That means the next box will now become box 2. And then the next box will become box 3. And then we need to delete the former box 3 so that it will look like the snake moved. To simulate this, we will need to set frame per second to a value. So we can start with 5. I will need to declare a variable to hold the direction that the snake will be moving in. So let's say that we start with the snake moving in the right direction. And then another variable for when we change the direction. So the snake is going to move with a speed as well. And for the snake speed, we're going to use the grid size. You need to also listen for more events. So this time we'll be listening to the keyboard using the pygame.keydown. When the user presses the up key, I like to change the direction of the snake to up. When the user presses the down button, I like to change the direction of the snake to down. The user clicks on the left arrow key. I like to change the direction of the snake to left. And when the user clicks on the right arrow key, the direction of the snake would become right. So I ensure that every time the snake's direction change, we update the snake direction variable. And if the snake direction is up, then we would like to reduce the snake position by snake speed. And if the snake direction is down, Then for the snake position, we like to add to the y-axis the snake speed. If the snake direction is left, reduce the x coordinate of the snake position. Oh, I need to make sure this is the y coordinate as well as the other one. This should be the y coordinate too. If the snake direction is right, then we need to increase the x coordinate of the snake position by the snake speed. So we ensure that the screen is filled to black, and we need to declare the constant that will hold the black color. To move the snake, since we don't have a function to prepend to the list, we use the snake body dot insert. At position 0, we're going to insert a list with the new snake position. That will insert box 0, and for the formal box 3, which now becomes box 4, we need to remove that from our list. So to set the frames per second for the clock, we use the clock.tick, and we pass frames per second. When I run the game again, you see that the snake is moving to the right. When I press the down arrow key, it moves down. When I press the left arrow key, it moves left. When I press the up arrow key, it moves up. And the snake is moving. All right. If you forget to clear the screen with screen.fillBlack, you see that each time the snake is moving, the previous position of the snake is still being drawn, which is not what we want. So we need to ensure that each time we're running the game, the screen is always set to black before we draw anything. Step 5 is to draw the food for the snake at random positions within the game's boundary. For the food color, I would like to use green. So I'm going to declare a new function called getFoodPosition, and basically this will return the food position where we want to draw the food. It will return a list of x and y values. I need the positions of x and y to be random, so I need to import the random module. So for x, we'll use the random.range function to get a random value for x. Within 3 and the boundary width I'm going to multiply all of that by the grid size to get the right proportion. And for the y, we'll do the same thing. Random.rand range. This time from 5 to the boundary height. Then I will scale that by the grid size. For our initial food position, I'm going to get food position, and then I'll declare a flag to indicate whether the food has been drawn on the screen or not. Now to draw the food, we use a rectangle. We'll draw a rectangle on the screen surface. This time the color will be green. And for the actual rectangle we'll be drawing, the x value will be food position x, which is the first value in the list of food position. And for the y, we have food position 1 for the second value in the list. And then for the width, we use grid size, and also for the height to be grid size as well. When you launch the game, you see that we have that green square as the food. And when I launch it again, the green square appears at a different random position. Step 6, we need to implement the game over function. So right now, when we quit the game, we run the pygame.quit and also sys.quit. So I'm going to put that in a new function called endgame. Let's replace this to endgame and test it. All right, so when we click on the close button, our game quits as usual. So for the game over function, we would like to declare a font using the pygame.font.sysFont function. Let's use the Times New Roman font. I like to use 50 for the font size. We're going to declare a game over surface and we'll render the font we just declared in it with the text game over and then the color which we'll define shortly. We're going to declare a game over rectangle. So we're going to get a rectangle from our surface. And we're going to set the mid-top position of our rectangle to screen width divided by 2 and screen height divided by 4. Draw the game over text to the screen surface using the bleed function. which will accept the game over surface and the game over rectangle. Then we'll update the display using the flip method. I'm going to set a time delay so that we can have time to read our game over text. And for this, I need to import the time module. Let's test the game over function. Click on the close button and we have an error. I think I have spelling mistake with the sys font. Launch the game again. You click on the close and this time you see the game over text before the screen closed. So I'll replace the game over here with game end. We'll use the game over function in other parts of the program later. So step 7, check for snake collision. The snake collides with the boundary, you want to call the game over function. When the snake collides with itself, you want to call the game over function. And when the snake collides with its food, you want to increase the length of the snake. So first things first, we check for when the snake collides with the boundary. So when the x value of the snake position is less than the boundary of x, or when the x value of the snake position is greater than the width, or when the y value of the snake's position is greater than the boundaries x, or when the y value of the snake's position is greater than the boundary's height. We call the game over function. So let's launch the game and test it. We'll let the snake go out of bounds. You see the game over text. This time, let's test that we can move out of bounds now. Game over is called. Let's test we can move out of bounds up. Game over is called. Let's test that we can move out of bounds left. Game over is called. If the snake position X is the same as the foot positions X, and the snake positions Y is the same as the foot positions Y, that means we've collided with the foot. And in this case, we'll just continue. Otherwise, would pop the last element of the snake. This will ensure that the snake continues to grow anytime it collides with the food. We collided with the food. You may not have noticed, but the snake grew by 10 pixels. We collided, it grew by 10 pixels again. You will notice that the snake is subtly becoming longer each time we collide with the food. I think now it's noticeable that the snake is much longer than when we started the game. But to make sure that the food actually disappears on each collide, we're going to set the food spawn flag to false. And then we're going to check anytime the food spawn flag is false, we want to spawn new food. So to do this, we need to get a new food position with the get food position function. And afterwards, we'll now set food spawn to be equal to true. When you collide with the food this time, the food disappears and respawns at a different position. One more time. You see that each time we collide with the food respawns and spawns at a new position. Now to test that we are colliding with the snake itself, we want to loop through all the blocks that make up the snake's body. And for each of this block, we want to test that the head of the snake, which is stored in snake position, is not the same as the position of that block. So we'll test for both the X and Y values of the block to make sure that they are not the same as the X and Y value of the snake's head. If they are, then we call the game over function. Let's launch the game and test it. Before we can test the snake colliding with itself, we need the snake to grow a bit longer. Now that the game is long enough, we can test that it can collide with itself and then display game over message. Now we need to count and display the player's score on the screen so that we can track the score of the player. So we'll start with a score of 0. Then we're going to define the display score function. This time, I'm going to use keyword arguments. For the font of the display score, we're going to get the font passed to this function by the font variable. Otherwise, if there's no font passed, we'll use Arial. And then for the size, we're going to check the size passed to this function as a variable. And if there's no size passed, we'll use 24 as the default size. For the score text, I would like to render the score. As I render the score, I like the score to be set to the color we pass as a keyword argument. And if there's no color passed, then we'll use the width color. Then I would draw the text to the screen using the bleed function, which will take the score text and also the position of X and Y for where the score text should be drawn. And to ensure that the score is always displayed on the screen, we'll have to call the display score function and pass in our keyword arguments. For the fonts, we like to use Times New Roman. For the size, we like to use 30 pixels. For the color, let's try brown for now. And for X and Y, we'll try 30 and 10 pixels respectively. And we have a syntax error. Keywords dot, that should be a dot and not a colon. Let's save that and try it again. And this time you see that the score is displayed on the screen. All right, so each time we eat the food, the score is not yet updating. So we need to remember to update the score each time we collide with the food. And that means here, I will increment the score by 10. Launch the game again. Eat the food, you see the score is being incremented by 10. Incremented by 10 again. To ensure the score is more visible, I'll change the color to wheat. And this time, we can read the score. It's more visible than before. Step 9, we're going to increase the speed of the game over time. And I'm going to increase the speed of the game every time the snake has eaten food 5 times. So to start off, we'll declare the food counter variable and initialize that to 0. So each time we collide with the food, as we increase the score, we also want to increase the food counter to count the number of times the snake has eaten the food. And then I'll do a modulus check with 5 to ensure that if we have eaten the food 5 times, then we will increase the frames per second rate by 10. Okay, so let's test that. 1, 2, 3, 4, and this is the fifth one, 5. You notice that the snake got quite faster. So I'll set that to 1 to increase by 1 frame per second and test again. One, 2, 3, 4, 5. And you notice that the increase is very subtle, which is what we want. We want the game to subtly increase over time. To increase the difficulty of the game a bit more, we're going to add obstacles to the play area and then detect each time the snake collides with an obstacle. Anytime that happens, we would call the game over function. So we need a new color for the obstacles. Let's use red. We're going to declare a variable to hold the number of obstacles we like to display on the screen at each time. And initialize that to 5. We're going to declare a get random obstacles function. And this function is going to return 5 different positions in a list. And the way to work will return x1, y1 as a list within a list. So this will be the first position. For the second position, we'll have x2, y2, and then we'll continue this type of format until we reach the fifth position, which will be x5, y5. And this is the type of data structure we would need for the random obstacles. But they all need to be random. Remember this piece of code to get a random position. So we'll replace that to get a random x and y. So this random x and y, just like the food, will be spawned within the game's boundary, the gameplay area. And then we would use a list comprehension to get the other positions for the other obstacles. All right, so obstacles would get, we call the get random obstacles function to get 5 random obstacles. And then within the game loop, we would like to draw these obstacles. So we'll loop through the obstacles. Then for each obstacle, we're going to draw a red triangle onto the display surface. So ensure for the rectangle, we also pass the X value of the obstacle, which is stored in position 0 of the list, and also the Y value of the obstacle's position, which is stored in the Y position on the list. And then for the width and height of the obstacles, it will also be grid size. We run the game again. This time you see 5 obstacles have appeared on the screen. We collide with them and nothing happens. So we need to test for collision with the obstacles. So we loop through each obstacle. And we check for collision between the snake and the obstacle. So if the X position of the snake head is the same as the obstacle's X position, or the Y position of the snake's head is the same as the Y position of the obstacle, then we have collided with the obstacle and we now call the game over function. When you collide with the obstacle, you get the game over text, then the game ends. To increase the difficulty of the game over time, we're going to double the obstacles each time we've eaten the food 5 times. So number of obstacles will get doubled, and then we want to get more random obstacles. So to test, you see we have 5 obstacles in the beginning at random positions. when we eat the food 5 times, we get 10 new obstacles randomly placed on the screen surface. Alright, so for this final step of the game, we need to add the game sound so that the game is more interesting for the users. So we'll add a sound for when the snake eats the food, and also another sound for when we have the game over function called as a result of colliding with obstacle or going out, or the snake going out of bounds. You've noticed I've added 2 sound files into the asset folder within the game. And to use sound, the first thing we need to do is to call the Pygame mixer init function to initialize the mixer in Pygame. Then we need to import the sound files using the pygame.mixer.sound function, and then the path to our sound, which is assets, and then the name of the sound file. These sound files, by the way, were downloaded from the Free Sound website. So in the game over function, we're now going to call the game over sound with game over sound.play. And then each time we eat food, we're going to call the eat sound.play function to play that sound. Now let's test the game. Oh, we get an error. Spelling mistake. So there should be an R at the end of mixer. All right, save that. Run the game again. Each time we eat the food, you hear the sound of the game. So you can find more useful resources with these links. Source code for this completed project, as well as the different steps, can be found in my repository. And you can find many free sounds in the Free Sound website. Thank you for hanging out till the end. If you enjoyed this, give it a thumbs up, drop a comment, and share it with a friend. Hit subscribe so you don't miss future videos, and check out this one on the screen. Catch you next time.